Okay, so go on. So in linear programming, what we said, we're trying to solve problems or optimize solutions based on what's called a graphical technique. So we're going to be drawing graphs, and we're going to be putting our variables. You guys are accustomed to graphs as in X and Y. Now we're going to, for our purpose, we're going to be doing X1 and X2. So X2 is basically your Y, and X1 is your usual X. A couple of things we went through in the last class. We said the symbol for greater than is this, greater than or equal to, right? And for less than or equal to, symbol will be there. We also said that we can say no less than, right? And if it's no less than, then it's greater than or equal to, right? And if it's no more than, we're talking about less than or equal to, okay? If we say at least, then we're talking about greater than or equal to, all right? So just bear this in mind. And this is greater than or equal to, just to let you, just for, you know, it's greater than or equal to. That's the equal sign there. That's the greater than sign there, right? So it's greater than or equal to. Let me just sure you're in tune. All right, so that's it. So that you need to know. I'm gonna take this off and move quickly. This is just a introduction. Make sure you remember that kind of stuff that you did. Sorry, before. All right. Sorry. So we're always, as you said, going to be trying to find something that looks like this to solve a graphical technique. But to do that, we need to set up the model. And the model basically has in it your objective function. That always has the money part in it, whether you're trying to maximize profit or minimize costs. Your objective function and what's called your subject to, and you'll see it like that, subject to. So it's the same thing as your constraint. Okay, now your constraint, right, are going to be these lines here. So whatever equations you get for your constraints, they're going to be represented by lines on the graph. So most problems are going to have 2 lines, but you can have 3, as you'll see later on when we look at some of the other tutorial questions, right? So I'm always going to be asking you to identify the variables. So you're going to determine, you're going to say, let x1 equal whatever it is based on the problem. And you're going to say, let x2 equal whatever it is in terms of the variables. So that when you solve a problem, you can say, what would be your optimum number of variables that you're going to be getting. All right. And then there's this, what's called non-negativity. Non-negativity. And all non-negativity is saying is that we're operating in this quadrant, because remember you have 4 quadrants. So over here, if I come on this side, everything on this side will be negative x1. If I come down here, everything on down here will be negative x2, that kind of thing. Okay? But we're going to be operating here where our x1 and our x2 must be greater than or equal to 0. Okay, so we're operating in that quadrant. Everything is clear so far. All right, and you guys need to be taking pictures quickly because I'm moving on. Right, so just keep you're snapshotting or you're taking a picture, just do it as you move along. All right, good. All right, so that being said, let's look quickly at a simple problem then. So question 6. Question 6. And it says you want to maximize 2x1 plus 3x2. So they've already told you what your variables are. They're going to be x1 and x2 for question 6. Everybody's looking at question 6. Remember I told you you need to have your problems in front of you so you can know where the numbers are coming from. Does everybody have their tutorial sheet in front of them? Linear programming, yes or no? Guys, I need a feedback or we'll be wasting each other's time. Do you have
Yes, sir, I have it. Yes, I have it.
Okay, good. So in this problem, it says you're trying to maximize. So this will be your objective function. You're trying to maximize 2x1 plus 3x2, okay? And it tells you that it's subject to, or I'm going to put in constraint here, so you'll know that it's one or the other, it doesn't matter. Subject to 1x1, 2x2, and that says, this statement says it's less than or equal to 6. And the other one says 5x1 plus 3x2 is less than or equal to 15. So those are your constraints. And now your non-negativity, writing it the way you should write it, even though it doesn't say it in the problem, but your non-negativity is x1, x2 is greater than or equal to 0. So that's what is all given to you in the problem. So it says to you, find the optimal solution using graphical solution procedures. And it says, what is the value of the objective function at the optimal solution? So we're going to have to find the optimal solution. All right. So you will realize that everything along here, right? Everything along the x-axis here, for these lines, for particular this line, where this line hits, x2 is 0. Can you see that? And everything along here, right, on the x-axis itself, right, x1 is 0, right? So to draw a straight line, basically, you need 2 points. Remember, we spoke about coordinates, and we write coordinates like this, remember? We said we're going to write coordinates. We always do it x, y, right? You guys remember, but here, we're going to be doing it this way. x1, remember we said x1 is x, and x2. So that's how we're going to write your coordinate. x1 first, and then x2. Always, always, always. All right? So let's get going to see if we can get something that looks like that. So what we're going to do is we're going to look at, remember we said each of these statements, and we can turn them into equations by just removing the less than, right? And just make it equal, and that then it's an equation. Each of these equations are going to represent a line there. So the way we're going to do this, we're going to write x1, all right, each of them, x1 plus 2x2 is now equal to 6. We turn statement into an equation by saying equal. All right, let me see, somebody's mic is on and making some amount of noise. All right, great, thanks guys. Yeah. Right. So what we're going to do, we're going to let x1 equal 0. And I'm going to go through first principle for the first 2 problems. And then after that, we're just going to breeze through because it's just basic math, right? So we're going to let x1 equal 0. So when x1 equals 0 in this equation, we're going to have 1 times 0. Everybody seeing that? I will let x1 equal 0. We're just substituting 0 in here for x1, right? Plus 2x2 equals 6. So 0 plus 2x2 is equal to 6. So then x2 is going to be equal to 6 divided by 2. Bring the 2 over, right? So x2 here is equal to 3, right? So now we can write one of the coordinates for this equation. And it's going to be, remember, you had met x1 equals 0, right? So it's going to be 0, 3, because your x2 is 3 when x1 is 0 here. We're then going to let x2 equals 0. When that happens, 1x1 plus 2 times 0, you know, substitute x2 into this equation, x2 equals 0 here, is equal to 6. Yeah? So then 1x1 is going to be equal to 6. So then basically x1 is equal to 6. So we can now write this coordinate, right, as 6, 0. Because remember, we said x1 is now 0, and we showed you all your right coordinates, right? The x1 first and then the x2, right? So that's for one equation. So that's one line. You would have one line set there, right? We can't draw yet. So what we're going to do now, we're going to look at the other equation. So the other equation is 5x1 plus 3x2. And that's now equal to 15. Again, we're going to let x1 equal 0. Like, I want to find x2. We know what x1 is. I want to find x2 for this. So when that happens, 5x, x1 is 0, so it's going to be 5 times 0 plus 3x2, and that's equal to 15, right? So 0 plus 3x2 is equal to 15. So 3x2 is equal to 15. Is equal to 15 divided by 3. Remember, I'm going through all of this little basic math stuff for the first two problems. After that, we just run it, right? So then you can write the coordinate for this point in this equation. It's going to be, remember, x1 was 0, so it's going to be 0. And so x2 is going to be 5, right? 3, 5, 15. So the coordinate is going to be 0, 5. Yeah? And then we're going to let x2 equal 0. When that happens, 5x1 plus 3 times 0 is equal to 15. So 5x1 is going to be equal to 15. So x1 is going to be equal to 15 divided by 5. So x1 is equal to 3. Your coordinate here is going to be x1 is 3. So it's 3 and 0 because x2 was 0. Okay. So now we have the coordinates that we need to plot that graph, right? Or something that looks like that graph. So what we need to do is we're going to do this. And this is going to be x1 here. And this is going to be x2 here, right? Yeah. Now we need to know how far our x1 goes, and we need to know how high our x2 goes. So we're going to look at the coordinates and see the furthest point or the highest point. So for x1, we look at all the x1s. So it's 0, 6. So 6 so far, 0, 3. So 6 is the farthest the x1 goes. Everybody see that? Furthest point for x1 is 6, is the largest. Look at all the x1s. Right? So we can say 1, 2, 3, 4, 5, 6. And let's look at the x2s now. So it's 3, 0, 5, 0. So 5 is the largest x2. So we can say 1, 2, 3, 4, 5. That's the only way you know how far to extend your grids on your graph. So now this is how we plot the graph. We come over here and we said when x1 is 0, x2 is 3. And we put a point here, right, for this equation. And when x1 is 6, x2 is 0. x1 is 6, x2 is 0. And we can now draw this line, straight line. Yeah, well, as straight as I can do it on a whiteboard, but you're going to have your ID, your ruler, all of that kind of stuff to draw your line with, right? So because this is the furthest point, I want to label this. I always want to label, because I have 2 lines or 3 lines, I want to know which line is which. And then come over to this line now, and it's 5x1 plus 3x2 is equal to 15. So when x1 is 0, x2 is 5. And when x1 is 3, x2 is 0. Yeah. So let me straighten this one up a bit. Yeah. All right. So now I can draw this line. Okay. All right. So I want to label this. I'll put it out here because this is the furthest point. 5x1 plus 3x2 is equal to 15. All right, so those I've labeled my graph, and you see it looks something like that, yeah? So not doing bad so far. Now then, what's next is we need to find what's called the feasible region. Feasible region is a region that conforms back to your constraints. Conforms to your constraints. So it must be less than this line and less than this line, right? So in this case, If it's less than the first line that we drew, it will be everything under that line, right? You guys got that? It will be everything in here. However, it must also be less than this line. So this line cuts it off. This line cuts this out of it. So now your feasible region is this area. And we usually ask you to identify the feasible region. Yeah? Okay? You with me so far? In terms of your feasible region?
Yes, sir.
So once you found the feasible region,
Sir. No, sir. Repeat that again.
feasible region must conform to your constraints. Here are your constraints back here. So it must be this line and less than this line. Okay? So
Okay.
that's here is your feasible region, because if you look at the first line that we drew, it would have been everything that's under that. It would have been
Less than, because of the less than,
this
right?
line cuts it off. This line cuts out this. So this is now your feasible region. All right. So we now need to find what's called the corner points. The corner points are the points at the feasible region. The corners of the feasible region is your corner points. So the corners are going to be here. So we call this A. Yes. B. Yeah. This is a C right here. Yeah. And there's a D right here where they intersect, where the two lines intersect. So those are your corner points. Those are your corner points. Are you seeing that? Are you seeing the corner points, guys?
Yes, sir.
All right. So we have to find the coordinates at the corner points. So guys, I'm going to take this off now, just to allow you to be able to draw the graph. I have more solving to do. I'm going to take this out. So you want to get this quickly. Did you guys get this snapshot or take a picture with your phone or whatever the case is? That just showed you how we got to that. So I'm taking this off now. I'm not hearing anybody squealing, so I'm taking this off now. Okay. All right. Okay, so after the feasible region, we need to find the coordinates at the corner points, and you'll see why, because those are the coordinates. Those are the points we're going to put back into our objective function. So you'll see everything coming through. This was the first problem, so don't stress or worry too much yet. All right, so we can say the coordinates at point A, the coordinates are going to be what? Anybody?
0 and 3, sir.
No.
3 and 0.
3, 0, right? 3, 0. At point B.
0, 0.
Yep, that's correct. At C.
0, 3.
Yep. Good. Catch on. Good, man. At point D.
2 and 2, if I'm correct.
I'll tell you why. It's just a rule because you want to be more accurate. So anything along the axes, any points along the axes, you can just read off the graph, right? And this should have been in your tutorial. But if it's inside of the graph, inside of the body of the graph, then you have to solve it, right? So I usually put something like this and say, I don't know. You guys will remember in high school, when two lines intersect, you can solve for the two variables by doing simultaneous equations. So to find point B, we're going to do what's called simultaneous equations. Now, to do simultaneous equations, you write each equation down and you subtract one from the other in terms of trying to find one of the variables or isolating one of the variables, right? And you're going to subtract, you modify the equations and then you subtract one equation from the next. So the first equation we had was 1x1 plus 2x2, and that's equal to 6, and 5x1 plus 3x2, and that's equal to 15. We can call this equation 1 and call this equation 2, right? So we want to modify the equations now. Now, I like to always just get rid of my x1. I mean, you don't have to. but you can get the array x2 and then that will give you x1, but I just have it, I guess. So if I multiply one equation by a certain factor, then I can then subtract to make sure that I isolate one variable. So if I multiply equation 1 by 5, that will get rid of x1, right? You see it? And this becomes 5x1 up here. So when I subtract equation 2 from equation 1, this is going to go, right? And I can multiply this by 1. Okay? So then, look at it. Solve this equation, because these are going to come up to you all the time in solving simultaneous equation, solving linear programming problems. So you have to master this. So here we go then. So this becomes 5x1 plus 10x2 equals 30. Is that correct? You see, we're
Yes,
multiplying equation 1 by 5 and equation 2 by 1. So this becomes, stays at 5x1 plus 3x2 equals what? 15. I'm now going to subtract one equation from the next. So everything in here becomes negative, right? So 5 minus, so this will be 5x1 minus 5x1. That will go. This is going to leave me with what? 7x2, basic math, but I know some of you guys not going to follow it, so, but it will come, and this will give me 15. So x2 then is going to be equal to 15 divided by 7. x2 then is equal to what? 2 point what? Run it in your calculators, guys. Guys, this is what? How many?
2.148, 2.142.
0.14. What I like to do, guys, I like to prep. Well, I call it prep. I like to take a look at my graph to see if it even makes sense. X2 is what I just found. X2 on this axis, and look at where it hits. Am I good or what? And I didn't have a straight edge like you guys do, right? So you can see, this looks like about 2, right? Are you seeing it? X2.
Yes, sir.
So I know I'm good. I know I'm good. So I need to find x1 now. So what I do is I'm going to substitute x2 into any of the two top equations. You can't substitute it into the modified equation. Any of the two equations up here. So equation 1 looks the easier one, don't you think? Substitute x2 into equation 1. x2 equals 2.14 into equation 1. When I do that, I'm going to get 1x1 plus 2 times 2.14, yeah? And that's going to be equal to 6. 1x1 plus, this is 2 4s 8, 2 1s 2, 2 2s 4, equals 6. So x1 is going to be equal to 1.72. Is that correct? Let's double check it.
Yes, sir.
1.7.
Yes, sir.
So what do I do now? Does it make sense? Look at this. I go over to my graph and I'm looking at x1. See it? It's almost like it lined up at about 2, which is good because I did it freehand, right? So I know I'm in a good right ballpark. I mean, if I had gotten, say, x1 equals 5.3, I would say, whoa, something's wrong. You know what I mean? And I'd have to look back over where I went wrong. But the best part is, well, the first one you find is what you look at quickly. 2.14, if I had gotten 5 or 4.2 up here, I'd say, no, definitely wrong. I mean, if I got 2.5, I'd say, in the ballpark, yeah? You know what I mean? Based on the graph. All right, so now that I've found that, I can now put what my coordinates are for D. It's going to be x1. Remember, you write x1 first when you're writing coordinates, 1.72, and x2 is 2.14, right? And I'm comfortable with that because I looked at my graph and it looks good. Yeah, and it looks good. The next step now is you're going to put these points into your objective function, because this is what you're trying to get at. So your objective function, you come back to your objective function here. And your objective function states you want to maximize 2x1 plus 3x2. And you say at point A, what's it going to be? 2 times, watch this, point A there, 3, 2, you're just substituting what the coordinates are, plus 3 times 0, yeah? Because remember, x2 is 0 at point A, right? And this will give you, what this gives you? 6.
Yes, sir.
At point B, it's going to be 2 times 0 plus 3 times 0. So that's giving me 0. At point C, it's going to be 2 times 0,
Sir.
3 times 3. See that? 9. See point C is 0, 3. Yeah? At point D, it's going to be 2 times 1.72 plus 3 times 2.14. What am I getting here, guys? This gives me 4. 2 7 is 14. 3 4 is 12. Do the math, guys. You have the calculator. Okay.
You have a brain, sir.
What do you get? 3.44 plus 6.42. That gives me 9.86. And I don't have the calculator like you guys, but so it is.
Yes, sir.
All right. So then,
Yes, sir.
right. So which point satisfies what I want to do? Which point?
At point D.
Point D, because I'm trying to maximize this. So point D, the way you write the answer then is your optimal point is point D. And at point D, you need to tell him what's going on at point D. You're gonna get 1.72 and 2.14. But see why we got D? Because we tried to maximize. In other problems, you're going to try to minimize, right? But in this, you're trying to maximize. So it's the one that gives you the maximum, right? And you're going to say the optimal solution is equal to 9.86. All right, so that's how we've solved this problem using linear programming. Okay, guys? I know it's just the first one, but I just wanted to show you the sequence, some of the methodologies that we use, you know, your piece of a region, your corner point coordinates, your solving simultaneous equations, that kind of thing, and then putting it back into your objective function. And that's how you solve it. All right. So with that said, if you need to take a picture, you need to take a screenshot, do that, because we're going to work now into a proper problem. That's just basically a simple one. So all of this here, guys, from here down, here, this is called your programming, linear programming model. And you usually get about 40% of your marks if you can come up with this. Now, this one was given, but when we look at, say, the question 7 that we're going to do next, you'll see it's not given, and you're going to have to pick out these numbers and set them up this way. All right. So let's go ahead and look at question 7. I'm going to switch the board now to the problem. So let's do that.
Hold on, sir. Hold on. Let me take a picture of this.
I just said that, you know. So you were taking pictures before, right? Because you need to get the sequence, because the board is small. If you
Yes,
were at university,
right.
right. If you were at the university, it would be one long thing and you'd be able to see steps, but I had to take stuff off the board. So hopefully you were taking all of those. All right.
Yes.
So let's look at a problem then. Question 7. All right. So Megan McCoy wakes up on Tuesday morning and remembers that she had promised the PTA she would make some cakes and or cornmeal puddings for its bake sale that afternoon. However, she does not have time to go to the store to get ingredients, and she only has a short time to bake things in her oven. Because cakes and cornmeal puddings require different baking temperatures, she cannot bake them simultaneously. She cannot bake them at the same time. She cannot put in cake and pudding in the oven at the same time, right? And she only has 3 hours available to bake. So you can see that's a limitation right there, right? Subject to, that's a limitation or a constraint, right? She only has 3 hours available to bake. A cake requires 3 cups of flour, and a pan of pudding requires 8 cups. Marie has 20 cups of flour. That's another constraint. She don't have more than 20 cups of flour, right? A cake requires 45 minutes to bake, and a pan of pudding requires 30 minutes. The PTA will sell a pan of cake for US $10 and a pan of pudding for US $6. Megan wants to decide how many pans of cakes and cornmeal pudding she should make. It says formulate a linear programming model for this problem, right? For your 40%, and then solve the model using graphical analysis. So let's go to this and I'll show you the approach. All right, let's go to the board. And see how we do the formulation of our linear programming model. Okay, so we're at question 7. So what I always tell my students is that when I'm doing linear programming, just draw the thing like this, the top of your paper, to let you know what you're trying to get at, and the procedures will come at you. All right. All right, so we're doing question 7. All right. First things first, we need to find our variables, right? So we need to let x1 equal what? And let x2 equal what, right? So a quick way to find out what your variables are is to look in the sentence that has your $sign in it, right? That has your money in it, right? So the PTA will sell a pan of cake for $10 and a pan of pudding for $6. So we can say, are we going to let x1 equal a number of cakes? Is that the cake came first? Yes. Number of cakes. And x2 is going to be equal to the number of puddings. And the way I write the exam, I'll always ask you what are the variables. So let x1 equal what? Let x2 equal this. And you get marks for this on exit, right? Number of cakes and number of puddings. And it's pans of puddings, obviously, but you know, it's number of cakes. All right. So that's getting the variables. And now we need to find our objective function or formula, same thing. Objective function now. This is where you're gonna find out what you're trying to do. What you're trying to maximize your profit, maximize your revenue, or you're trying to minimize your cost. So in this case, it's a PTA. So what they're trying to do is maximize their revenue, right? So again, you look in the $sign line and it says a pan of cake will sell for $10. So the number of cakes I make, so it's going to be $10, right? Times the number of cakes plus $6 times the number of puddings. And I'm trying to maximize that. I could have put the max here, it doesn't matter, but you're trying to maximize this. So this is your objective function. Everybody see this? Your total revenue that you're going to make is $10 times the number of cakes that you sell, plus $6 times the number of puddings that you sell. See it? Got it? Clear? Yes or no?
Yes, sir.
I thought the dollar sign, but that's okay.
Can you explain it again, please?
What am I explaining?
I'm asking you to explain it again, please.
I'm trying to maximize my revenue, because when you sell cakes at any sale, you're trying to maximize your revenue. Is that true or no? Yes or no? You have to come with me, guys, so I know what you're understanding or not. Yes or no?
Yes, sir.
Right. So do you see that my total revenue is going to be $10 times the number of cakes that I sell, plus $6 times the number of puddings that I sell? Are you seeing that?
Yes, sir. Okay.
Good. So that's what that is. But now I gotta put the constraint, subject to, or constraints. Now my constraints, right, are going to be my time available to bake and my cups of flour that I have, right? So I can write my constraints in terms of X1 and X2. So in terms of the cups of flour that I have, it says a cake requires 3 cups of flour. So 3x1 plus, and a pan of pudding requires 8 cups.
Yes, 8x2.
And that, right, is less than or equal to, because that's all she has, right? Equals 20. Are you seeing that? She has 20 cups of flour. That's all she has. So it can't be greater than that, right? Now, the other constraint, so that's flour. Other constraints you're going to have is in your time. So what are the constraints? It takes 45 minutes to bake a cake. So the number of total time it's going to take me to bake the cake is 45 minutes time the number of cakes, right? Times the number of cakes. That's how long it's going to take me. Plus 30 minutes for the pudding. So it's 30 minutes times x2. That will be my total time. Less, and that must be less than or equal to
3 hours.
3 hours. But because you have minutes here, you have to convert the 3 hours to minutes. That's all, right? So it'd be 180. That's all. 60 minutes in an hour. So you just convert it. You could have done it the other way and convert the 45 minutes to hours, which would be 0.75. Yeah. And this will be 0.5. But you know, let's run it that way. And this is your time. Right? So those are my 2 constraints. So looks like I'm looking at my 2 lines up there. And I want 1 mark, because when you put this in, you'll get 1 mark. Non-negativity. Non-negativity, which is where x1 and x2 is greater than or equal to 0. All right. So that's my 40% of the mark for this question right here. Okay. Everybody get this? Look back at your constraint. 20 cups of flour, right? And the total, so I need to find out the total amount of flour. Well, it's going to take me, but it must be less than 20 because all I have is 20 cups of flour, right? So 3 cups times the number of cakes that I make, that will give me my total number of cups of flour that I use up for cakes, plus 8 times the number of puddings that I make, right? But that sum must be less than 20 cups. Clear? Same thing for the time. All right, so let's get going. So we have this. Now we need to try to get to that. So again, we look at each equation. We look at each equation. So first equation, 3x1 plus 8x2. I'm going to turn it into an statement. We'll turn it into an equation now. Equals 20. Again, the usual, let x1 equals 0. And I'm going to go through this. The only one is the last one I go through first principle in solving for the coordinates to plot the graph, right? So we let x1 equals 0. So 3 times 0 plus 8x2 is equal to 20. So 0 plus 8x2 is equal to 20. So x2 is equal to 20 divided by 8. x2 is equal to what? Guys, roll this in the calculator and let's move on. Something like this shouldn't take us so long. Just tell me 20 divided by 8 quickly.
2.4, sir. Wouldn't it be 2.4?
2.4. All right, that's fine. So then I can write the coordinate. Always, it's going to be 0, 2.4, right? Remember, I write the x1 first, and that's x2 you solve for. And then you're gonna then let x2 equals 0. When x2 equals 0, you have 3x1 plus 8 times 0
20
equal 20. 3x1
plus 0
plus 0 equal 20. So x1 is going to be equal to 20 divided by 3. What's that?
6.7.
6.7. So I can write the coordinate now, 6.7. 0. I remember they make x2 equals 0. Okay? So let's go to the other equation now. The other equation is 45 x1 plus 30 x2 equals 180. Right?
Let x1 equals 0.
Right. Again, let x1 equals 0. When that happens, 45 x1, 45 times 0 plus 30
x2
x2 equals 180. 0 plus 30 x2 equals 180. x2 is going to be equal to 180 divided by 30. x2 is going to be equal to what's that? 6. Yeah?
Yeah.
Write my coordinate, right? Which is 0, 6. And then I'm going to let x2 equals 0. When that happens, going back to the equation, 45 x1 plus 30 times 0 equals 180. So 45 x1
Plus
equals
0
180. So x1 is equal to 4.
by 4.
Right? I can write my coordinate now. What's a coordinate? Buddy?
4 and 0, sir.
4, 0. So now I'm ready to plot my graph. Ready to plot my graph. So this is my x1, and this is my x2, right? So how far does my x1 go? Let's see, 0, 6.7, 0,
6.6.
so 6.7. So I can call it 7 for simplicity, right?
Yeah.
Call it 7. So I can say 1, 2, 3, 4, 5, 6, 7. And my x2, where do I go? 2.4, 0.4 still, 6.
Yeah.
That goes to 6. You see it? All right, now I'm ready to plot my graph. All right, so I come back to this first equation here, and my first point is when x1 equals 0, x2 equals 2.4. So 2.4 just a little below the middle point, right? 2.4. And for the same one, when x1 equals, call it 6.7, so a little bit above 6.5. x2 equals 0, I can draw this line. Wow. It's kind of not the best line, so when we look back, it might be a little off, but that's okay. And then for the next equation, which is the 45, when x1 equals 0, x2 equals 6,
Yes.
and when x1 equals 4, it's that, okay? So I can draw this line. Right. All right, so now I need to find the feasible region. Feasible region, I come back to my constraints, because those lines must conform to the constraints that I have. Let me see something. Yeah, it's a little off. Let me just draw it a little bit more. Or try to draw it. Yeah, so it's better. All right, so I need to find my feasible region. My feasible region, just like the problem before, it's going to be here. You need to know to find a feasible region, because if you don't, you're going to get the graph wrong, and your corner points are going to be wrong. So it has to conform to these two. So it's less than, so it's that, right? So my corner points are going to be here, A, B, C, and D, right? So
Yes, sir.
I write my coordinates at my corner points. So at point A, what's my coordinate at point A? It's going to be 0,
okay.
right? At point B, it's going to be 0, 0. At point C, it's going to be, what's that, 2.4 it was, or 0, 2.4? 0, 2.4. And at D, I don't know. See it? D, you don't know. Then you have to solve simultaneous equations to get that. So I'm going to take this off because this was just helping me to plot the graph, right? So I'm going to take this out. You guys hear me? I'm going to take out the middle section to create some room. Everybody heard that, right?
Yes,
Sir, hold on there. Hold on, sir. Hold on, sir. You can go ahead now, sir.
All right, so I'm going to solve some simultaneous equations. So the two equations are 3x1 plus 8x2, and that's now equal to 20, and 45x1 plus 30x2, that's equal to 180, right? So this is equation 1 and this is equation 2, okay? So I can multiply equation 1 by 15. And to know what you need to multiply it by, you can just divide the larger number by the smaller number that you're trying to eliminate the variable. So I'm going to go 45 divided by 3, give me 15. Everybody see that? Everybody see that? Because remember, I'm going to come back and multiply it, so it will take it out, right? So then it's going to be 45 x1 plus, what's 15 times 8? It's like 300, maybe. If it's not 300, tell me quickly. Let's move on.
120.
How much is it?
It is 120. 120.
All right, good. You guys are awake. And what's that? 300, right? And then this will be back here. 45x1 plus 30x2 equals 180. Yeah? Subtract one equation from the next. This is going to go, this turns this to negative 30. So this will be 90. X2 equals what?
120, sir.
120. So then my x2 is equal to 120 divided by 90.
Okay.
X2 is equal to what?
1.3, I think. Okay. Yeah.
I don't know.
I mean, I got 1.3.
1.3, sir.
1.3. All right. So I look at my graph to see if it makes sense. X2 is what I just found. It should be 1.3. Right now, it's about 2. Because this line is flat, it shouldn't be. It should be slanted. So I can say it's probably, I'm sure I'm correct. But it's close. It's not giving me 5 or 6 or anything like that, right? So that's why you have to solve it. Because if you had just looked at the graph, you would say, 2.9 or 2.7. Sorry, can't be 2, yeah, 2.9 or 2.7. No, this would be 2.5 here. So you'd probably say
You're finding these, sir. So it's
X2, finding X2, finding X2. Finding X2. But all I'm saying is you look at the graph and you can tell sometimes, right? But this one, because I drew it, I didn't draw it correctly. It should come down a little bit more. Understand? That's why you need to solve it, the equations. Then you're going to substitute X2 equals 1.3 into, I don't know which equation, maybe equation 1 again is easier, into equation 1. So now you're going to get 3x1 plus 8 times 1.3 equals 20. So 3x1 plus 3 4 is 12, no, 3 8s are 24. 10.4 equals 20. So 3x1 equals, what's that? 9.6. x1 equals 3.2. I come over here, I just like to look to me, see if it makes sense. When you guys draw your graphs with straight line, you'll be more accurate. But look at this. You see that x1 is pretty good? Yeah? Are you seeing it? X1 is pretty good. So I'm comfortable with my coordinates. So now I can write what my coordinates are. It's going to be 3.2 and 1.3. Okay? Now that I have my coordinates, I can then substitute my coordinates into my objective function. Which is trying to maximize 10x
X.
1 plus 6x2. So at point A, what's this going to turn out to be? It's going to be 10 times 4, because I'm looking at point A up here, plus 6 times 0. That's going to give me 40. At point B, it's going to be 10 times 0 plus 6 times 0.
Equals 0.
0. At point C, it's going to be 10 times
0.
0 plus 6 times
It's 2.4.
4. What's that?
That's 12.8 to the mid.
6 4. No, can't be right. 6 4s is 24.
24.
So 4 must be here.
Oh man.
And 6 2 is 12. And 2 what? 14.
14.
Yeah. All right. And then for D, it's going to be 10 times 3.2
1.2.
plus 6 times 1.3.
1.3.
What do you get here? So that's 32 plus
32 plus
7.8. $39.8. Yeah. And you guys have the calculator. All what? 18 of you have the calculator.
also remember brain, sir.
Well, try to follow your brain how to get this wrong.
Sometimes I have to get some things wrong, sir.
But at least you participate. That's what's important.
Yeah,
So,
the
so,
optimum point
so
is
what's
A.
my optimum?
The optimum point is A.
Optimum point, and this is where you're going to write it now. Optimum point is A.
A.
This maximize it, and I need to tell them what's happening. So then I'm talking about 4 cakes. Right? Remember, X1 is cakes.
Yeah.
And no pudding.
No.
I'm not taking no pudding. Based on my
Solution.
constraints. And my optimum
Solution.
solution is how much money I'm going to make?
$40.
$40. All right, so there you have it, guys.
Sir,
Yes.
me have on my tutorial sheet and work it out. We get the $40, but like for your points, them it's different from what's on this sheet. Cause like me get 140. Me see I have that. Me see the next one, me see 18. Me see I have not 18. And one the next
Anything
one.
you have on
37.
your sheet is incorrect. I'm telling you, this is correct.
Okay, so the sheet incorrect. That's more I know, but then get the 40 same way. Me still I take your notes them now, so me just I tell you.
So you
18 for which
I know one
where
writing the paper exam, so I mean you can
where is the 18?
decide from there. All right, so we need to press because we've gone 1 hour already, guys. And there's some other things we want to talk about. So do you guys have that? I want to look at another problem, which I know some of you guys would have gotten wrong. There's 2 more problems we need to do. And then I'll set you on your own to work some problems and come back to me with them. So that's 7. I'm gonna skip 8 and then come back to it right after this. So we're gonna do 9 and then come, no, not 9. We're gonna do 8, 10, sorry, and then come right back to 8, because we have to do 8. 8 is a little different, so we have to do 8. I just want to point out something to you on question 10, which some of you might have issues with. Okay. All right. So if you don't have this, take it now because we're taking it off the board. All right. Going once, twice, gone. So that wasn't too bad in terms of time, actually. And we're hoping you guys grasp that. So we're moving to question 10, as we said. So here we go, question 10. And we're going to come back to 8. We have to do 8. Question 10. It says, oops. Yeah. So Pinewood Furniture Company, right? Are you seeing it?
Yes, sir.
Pinewood
Yes,
Furniture Company produces chairs and tables from 2 resources, labor and wood. Company has 80 hours of labor and 36 pounds of wood. So there's your constraint right there. You only have 80 hours of labor and 36 pounds of wood, right? Available each day. The demand for chairs is limited to 6 per day, and each chair requires 8 hours of labor and 2 pounds of wood, whereas a table requires 10 hours of labor and 6 pounds of wood. The profit gained from each chair is $400, and from each table, $100. The company wants to determine the number of chairs and tables to produce each day in order to maximize profit. Says the usual, find the optimal solution using graphical solution. What is the value of the objective function at the optimal solution? All right, quickly, what are your variables?
Let X be the first one. X1. Wait, was it labor?
No. Again, I told you how to know what
Oh,
your are.
yes, a variable, sir.
Sign that has the dollar sign.
Yes, yes. Chairs on table, sir. Sorry.
Exactly.
And your optimal lobby, let X1 be 400, and then, you know.
So we're gonna let X1 equal number of chairs,
Mhm.
and let X2 equal number of tables. Everybody see that,
All right.
guy?
Make a mistake. Wait a minute.
Yes,
Everybody
sir.
sees that and understand what I just said. All right, fine.
Yes, sir.
All right, so all right, so this is question 10. We're gonna let X1 equal number of
Chairs. And let X2 be number of tables.
all right, your objective function now. Anytime you're doing anything, selling something, you
It's
always
max 400 X1.
What's it?
Max 400 X1 plus 100 X2.
Everybody see that? Does anybody not see this? All right, so everybody, someone like to see it. So you're gonna so your subject to or your constraint. You don't have to write or. Anyone in the test, right? ST or constraint is fine. So your constraint is now going to be, anybody wants to tell me what the constraints are going to be? The equation?
I was saying that I would say like 80
80 hours of
X1,
labor.
80 X1.
No, totally wrong. You have 80 hours. All you have is 80 hours.
Yeah.
That's where
And
that
36 pounds of wood.
36 pounds of wood. So that's where that 36 goes. So that's all you have. Now you need to talk.
All right, so 8 hours of labor and 2 pounds of food is less than or equal to 80.
No,
Not that.
1 plus what?
2 pounds of food, sir.
Huh?
2 pounds of food, it says.
No, but this is your labor, you know.
Oh, 10
So you see.
10 hours, sir.
You're
No.
all the way around.
Ten, sir. 10 for the labor. 10 for the labor and that's okay. I forgot.
Look to see if you get this, guys. Read the
Yes,
problem.
sir. Yeah, it's group data, so you have to group them together.
Read the problem more than once and make sure you're doing the right thing. And then your non-negativity
It's 0.
x1, x2 is greater than or equal to 0. All right. Make sure you see how we got this. Does anybody not see how we get this? All right. Now there's more things we need to add to the problem.
Sir, I never see you. Can you repeat again?
What do I need to repeat? How you get this?
Yes, sir.
So there's your constraints are 80 hours of labor and 36 pounds of wood. It tells you what each chair contributes, right? Each chair requires 8 hours of labor and 2 pounds of wood. See, so my labor is up here from a chair, and my wood content is up here, is down here from a chair. So everything here is chairs that I'm dealing with. Plus, now I come over here to deal with what is required for tables, right? So look in the problem. It's kind of ridiculous for me to explain because you have to look at the problem. If you're not looking at the problem, you're not going to know where the numbers are coming from. You understand what I'm trying to say to you? You have to be looking at the problem. Are you looking at the problem? Do you have
Yes,
it?
sir.
If you don't, it's pointless me even going over this. You have to see where the numbers are coming from. Now, there's one thing we left out, right? And in linear
We put in a demand for 6 each day.
x1, right, will always be less than 6. There. So in linear programming, all the numbers are relevant. So you need to look for all your constraints because x1, the demand is less than 6. Okay. All right, let's go ahead now quickly then and set it up to get to something like that. So as usual, 8x1 plus 10x2 is equal to 80. So here's where I go fast now. Let x1 equal 0, x2 is going to be equal to 8. And your coordinates are going to be 0, 8. You're going to let x2 equal 0. When that happens, x1 is going to be equal to 10. So your coordinate here is going to be 10, 0. Going to look at the other equation now. 2x1 plus 6x2 is equal to 36. You let x1 equal 0. When that happens, x2 is equal to 6. Coordinate 0, 6. Then you let x2 equal 0. When that happens, x1 is equal to 18. The coordinate 18, 0. Okay. Now we're ready to draw the graph. Let's see. X1, x2. So again, what's the largest x1? 10, 18. So we can say 2, 4, 6, 8, 10, 12, 14, 16, 18. Shouldn't have done that because I take it too far for me to draw.
Yeah, by 3.
And what's your largest x2? 8. See it?
Yeah, yes, sir.
So you can say 1, 2, 3, 4, 5, 6, 7, 8. All right, when x1 equals 0, x2 equals 8. When x1 equals 10, x2 equals 0. So those are your 2 points for that line. Draw that. Since this is the furthest point, I can 8x1 plus 10x2 equals 80. Have to write your equations on your lines, guys, and you're going to see why. And for this line, when x1 equals 0, x2 equals 6, and 18.
Good luck.
All right. You have to draw this line. X1 is less than 6. So x1 is less than 6, it's just a vertical line all the way up. x1 equals 6. Yeah. So now, to find your corner point, it must conform to all your constraints here. It must be less than this, and less than this. So the feasible region would have been just here if you never had the less than 6, right? But now the less than 6 cuts off this area, so this is your feasible region now. Are you seeing that? Has to be less than the 6 line also. Are you seeing that?
Yes, sir.
All right, so your corner points now become here, A, B, C, D, and look, I have another one, E. See it?
Yes, sir.
All right. So,
Sir, does it matter in what direction you label?
not really, but because one person marking the paper, you want to stay consistent, so you just go clockwise. All right, for consistency. You understand?
Yes, sir.
All right, so here, watch this now. At point A, what are your coordinates?
6 and 0.
0. At B, what are your coordinates? 0, 0.
No.
C, what are your coordinates?
C, sir. We can't be able to see.
What's that? 7, 0?
I know that's like is that a 1, 2, it's 6, sir?
6, 0. Yeah.
6, yeah.
No, 0, 6.
Yes, sir.
Yes, sir. 0, 6, sir.
D.
You have to find D, sir.
Or you going to that?
Also find simultaneous equation.
Right, and E.
Also simultaneous equation.
It's not really simultaneous equation, but I'll show you how. You know what your
You have
x1
one of them for
Yeah.
you're only finding
right,
x2.
and then now you need to
Can I
find.
substitute
You
one
know,
to other?
going to substitute whichever line it crosses here, which is the 8x1 plus 10x2. Can you see that? You see the 6 crosses
Yes,
this.
sir. Let's substitute the 6 into it, sir.
Substitute x1 equals 6 into this equation, and that will give you your
X2.
right.
Okay.
So to find
Yeah.
this one, you substitute. I'm not going to do this because you know what to do simultaneous equations. Now we've done enough of those. You're just going to substitute x1 equals 6 into which equation it intersects, which is the 8x1 plus 10x2 equals 80. Okay. And so this will give you 8x1. Well, we have x1
So yeah, you have x1, so you have to be 8 times 6
plus
x2 equal 80.
equals 80. 6 8 is what? 48 plus 10x2 equals 80. 10x2
Equal 128. Carry like term, sir. You know, carry like term first.
What like terms? You have 48 equals 10x2 equal 80. So you carry over the 40.
Yeah, minus, yeah.
Right, you minus. So you get
3.2.
2.
Yeah, like 10x2.
2
Right, but right then.
3.2. Look and see if it makes sense. Here it is. And again, I told you I drew my stuff without a straight edge. So I'm very good actually. You see it? Are you seeing it? Guys, are you seeing it?
Yes, sir.
Okay, fine. So now I can write my coordinate here. It's going to be 6, 3.2. As I said, D, you know to do the simultaneous equations. You can work that on your own. Time is not our friend. We need to move on. You can take a picture of that. Right? And this is the problem, question 10. We're going to try question 8 now. You guys have that?
Yes, sir.
What's your time like? Oh, not so bad, not so bad. But you guys understand that I didn't finish the problem though, right? But I've showed you how to do it. Once you know calculate your D using simultaneous equation, you substitute into your objective function to see which one satisfies it in terms of maximizing 400x1 plus 100x2. All right, and we've done 2 or 3 of those already. I just wanted to show you this, right? It's your basic math from high school, though, you know, but I still wanted to at least give a little refresher. All right. Everybody good with that?
Yes, sir.
So far.
Yes, sir. Yes, sir.
Okay, let's do question 8. I'm taking this off. Backing up to question 8. All right. So Munchie's cereal company, right, makes a cereal from several ingredients. 2 of the ingredients, oats and rice, provide vitamin A and B. The company wants to know how many ounces of oats and rice it should include in each box of cereal to meet the minimum requirements of 48 milligrams of vitamin A, right? So there's a constraint, and
Yes.
12 milligrams of vitamin B, while minimizing cost. You heard what I said? While minimizing cost. An ounce of oats contributes 8 milligrams of vitamin A and 1 milligram of vitamin B, whereas an ounce of rice contributes 6 milligrams of A and 2 milligrams of B. An ounce of oats costs 5 cents, and an ounce of rice costs 3 cents. What are my variables, guys? What's
Let
my
x1 equal oats and let x2 equal rice.
exactly? All right, so you catch on now. All right. So I'm gonna let x1 equal, and it's ounce, but that's okay. Ounce of oats. I'm gonna let x2 equal ounce of rice. Does anybody not see how we got this? All right, good. After we do that, we now need to talk about our objective function. Right? Our objective function is we want to minimize our cost.
Yes,
Right?
sir. So minimize. So min
It's going to be 0.05
Yep.
x1
x1
plus 0.0.
0.03 x2.
Everybody not see how we get this? All right, good. Good.
Sir, are there some funny? You may not see a board if you show your board.
Oh. Yes. So you saw we got x1, x2, the variables, what they are, and you see this is your objective function. You're minimizing your cost. Your cost for an ounce of oats is 5 cents, and your cost for an ounce of rice is 3 cents. So this will be your total cost, and you're trying to minimize it. Got it? Now you're subject to now, or your constraint, whichever term you want to use. Right? All right, so our constraints
Is 8x1. 8 ounce. 8x1, sir. Right?
so my constraint, and so I'm doing it, is my vitamin A and my vitamin B.
Yes, sir. Yeah, that one would be 12.
Right? And it says it's a minimum requirement. So now I'm talking about greater than or equal to, because it's a minimum requirement.
Yep.
Follow? And so now it says the company wants to know how many ounces of oats rice should run. Rather
So
than
8x1 plus 6x2.
says an ounce of oats contributes 8 milligrams of vitamin A. So that's my oats. and 1 milligram of vitamin B. Right? Are you seeing that?
Yes,
See
sir.
how I'm approaching it? Are you seeing the approach? Whereas an ounce of rice contributes 6 milligrams of vitamin A and 2 milligrams of vitamin B.
B.
Many of you would not have gotten this right. I know that, but that's okay.
But I gotten that right, sir.
You would have. Okay, good.
I said 8 plus 8x1 plus 6x2.
Okay, and then you have non-negativity. That's good. That's good.
And not equal to
Is the usual x1, x2 is greater than or equal to 0. And that is your model. That is your model, guys. All right. So now that we've gotten our model, everything else now becomes easy, right? We're gonna find each equation. So 8x1 plus 6x2 is now equal to 48. And of course, the usual, let x1 equals 0, then x2 is going to be 8, right? So you're gonna have 0, 8. Again, you're gonna let x2 equals 0. When that happens, x1 is equal to 6. So then you have 6, 0. Look at the other equation. What's it? 1x1 plus 6 plus 2x2 is equal to 12. Let x1 equal 0. When that happens, x2 is equal to 6. 0, 6 is your coordinate, and you let x2 equal 0. When that happens, x1 is equal to 12, right? Coordinate 12, 0. So now we can plot our two lines, right? That way there. X1, X2. Largest X1, 12. All right, X2, what's my largest X2? 8. All right, so ready to plot. When x1 equals 0, x2 equals 8. And then when x1 equals 6, x2 equals 0. So that's my point for that one. I can plot. This is the furthest point, so I can write my equation here. 8x1 plus 6x2. I hope you guys saw the importance of writing the equation. That last problem that we looked at, if you didn't know which one the E intersected, that straight line, you would have, been out. All right, let's look at the other line now. When x1 equals 0, x2 equals 6. And the furthest point now goes to 12. So I can draw this line. Okay. All right, but now look at this. I now need to find my feasible region. Once I've drawn that, I need to find my feasible region. My feasible region must conform to these now, but it's now greater than. It's greater than lines. So my feasible region is going to be here. Watch it. It's greater than everything on this line. Right? And it's also greater than everything in this line. It couldn't be anything in here because then it wouldn't be greater than this line. Can't be anything in here because it wouldn't be greater than either of the lines. It can't be anything here because then it wouldn't be greater than this line. See it? So this is my feasible region now. It's almost going to infinity. You understand? That's my feasible region. So it could take me to infinity basically. Once I've found that, I now need to label my corner points. Corner points are going to be A, right? B, and C. See it? That's my corner points. So my coordinates at my corner points at point A, what is it?
12 and 0, sir.
Well, 0. At point B,
0 and 8 are largest number. Yeah, about there, sir.
and at point C,
Define that.
right? So let's solve simultaneous equations to get that then. C. It's going to be 8x1 plus 6x2 equals 48. And the other one, 1x1 plus 2x2 equals 12. That's equation 1, that's equation 2. Right? And I'm going to try and modify those equations. You can see that I can quickly, but I like to do multiply this by 1, multiply this by 8. Never had to. I could have multiplied this by 1 and multiply this by 3. So I gotten rid of my x2 and that will show me x1, but you know, the usual. I'm gonna do this. So it's going to be 8x1 plus 6x2 equals 48. And then I'm going to have 8x1 again here plus 16x2 equals, what's that? Well, it's 96, right? And I'm going to subtract. This is going to turn to minus 10. X2 equals minus 48. So my X2 is going to be equal to 4.8. And look up at the graph. Pretty good, right? Yeah? Are you guys seeing that? X2, I'd say this
Yes,
is
sir.
4.1, but yeah, good enough, right? So then I'm going to substitute 4.8, and you're experts at these now, into equation 2 this time. Look easier, right? Equation 2 is going to be 1x1 plus 2 times 4.8 equals 12. Remember now, it's an unmodified equation, you have to put it in. You understand? The unmodified equation. So then x1 is plus, what's that, 9.6 equals 12. X1 is going to be equal to 2.4. Yeah, maybe. And there you go, looking good. So I'm confident that that's right. So now I can write what my going to be 2.4, 4.8. Yeah. I'm going to come around here now, and I'm going to go back to my objective function. I'm going to take this. I'm going to take this off. This is just to let x1 equal 0 and all of that kind of stuff, right? And you know negativity. So you know all of that now by now. So I'm going to come back to my objective function. Sorry. My objective function, which is 0.05 x1 plus 0.03 x2, right? So at point A, it's going to be 0.05 times 12 plus 0.03 times 0. That's going to give me 0.6, right? That times that. At point B, it's going to be 0.05 times what's B? 0 plus 0.03 times 8. Are you guys seeing where the numbers are coming from? Anybody not seeing where the numbers are coming from? You're taking it from the coordinates that you found. C is going to be 0.05 times, what was C? 2.4 plus 0.03 times what? 4.8. that's going to be equal to 0.26. So now I can say what's my optimum point? Anybody? What's the optimum point?
Maybe 0.6,
0.6, sir.
let's minimizing, sir. So that's a
0.4.
0.4.
24, exactly. But what's the point? B.
Yeah, at point.
Yes,
Yeah.
sir. Point.
And you have to tell them what's happening at point B, where you're gonna say it's no rice, 0 R's oats, no oats, and 8 ounces of rice. All right, and your optimum solution is 24 cents. All right, so that takes care of that. So I'm imploring upon you guys, let me show you. Question 15. Most of these can come in your exam, but question 15 is the format that we like to put it in, just to let you know, where you have to find your X1, your X2, and all that kind of stuff, and your objective function, and that kind of thing there. Stop recording.